Hello there, and welcome to the Sleepy Space Channel. Everything in the sky is spinning, and nothing ever started it. The Earth beneath you turns, giving you your days. The sun turns, the moon turns, the planets and the far stars turn, and the great wheels of the galaxies turn with them. Yet not one of these was ever set going. No hand wound them up, no push sent them spinning, and still the whole universe refuses to hold still. Where all of this turning first came from, long before there were any planets or stars to carry it, and why a few strange worlds turned the wrong way entirely, is one of the deepest and quietest questions in all of astronomy. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next couple of hours, none of this is a question you need to solve. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away behind you, and let the turning of the world carry you gently toward sleep. Let's begin. Part 1. Everything is turning. Begin with the sky you already know. The sun rises in the east and settles in the west, and it does this not because it travels around us, but because the ground beneath you is turning. The Earth rotates, once each day, carrying you with it through light, and then through dark, and then into light again. Every sunrise you have ever seen was the planet turning your part of the world back toward the sun. The day itself is nothing more than the name we give to one full turn. The moon turns as well, though it hides the fact. It rotates exactly once for every circle it makes around us, so it always shows the same gentle face and keeps the other side turned away. The stars wheel slowly overhead through the course of a night, tracing quiet arcs, and this too is the turning of the Earth, not the turning of the stars. Wherever you look in the sky, something is rotating, and most of the time you cannot feel it at all. Move outward from the Earth, and the turning does not stop. It multiplies. Every planet that circles the sun is also spinning on its own axis, each at its own steady pace. The great gas giants turn quickly, wrapping themselves around in a matter of hours. The smaller rocky worlds turn more slowly, marking out their own days. Not one of them stands still. Rotation is not something a few planets happen to have. It is something they all have, without exception. The sun itself is turning. It is an enormous ball of glowing gas, and it rotates roughly once a month, carrying its bright surface around in a slow and steady wheel. Look further, to the other stars scattered across the night, and every one of them is spinning too, some in days, some in weeks, the fastest of them in mere hours. Beyond the stars, the galaxies turn, enormous wheels of light so large that a single rotation takes hundreds of millions of years. Even the collapsed remnants left behind when stars die are turning, some of them faster than anything else in all of nature. Consider how strange this really is. When you set an object down on a table, it sits still. Stillness feels like the natural state of things, the way the world rests when nothing disturbs it. And yet, when we lift our eyes to the universe, we find almost nothing at rest. The planets turn. The moons turn. The stars turn. The galaxies turn. Stillness, which feels so ordinary here on a tabletop, turns out to be one of the rarest conditions in the cosmos. Almost everything everywhere is quietly in motion around some axis of its own. This is the pattern that runs through everything we will explore tonight. It is so universal that it flips the question we might first think to ask. We do not really need to wonder why a few special objects happen to spin. We need to wonder why everything spins, all of it, at every scale we can reach. From the smallest tumbling fragment of rock to the largest wheeling galaxy, the whole universe seems to be turning, and it seems to have been turning for as long as it has existed. There is a temptation to imagine that the turning was somehow switched on, that each planet and each star was given its spin at the moment it came into being, like a topset going by an unseen hand. But nothing in the sky was wound up and released. There was no push, no starting shove, no moment when the stillness ended and the turning began. And this is the quiet mystery at the heart of the whole story. If nothing gave these worlds their spin, then where, exactly, did all of this turning come from? Hold that question gently as we go. Do not reach for the answer yet. Let it sit unresolved for a while, the way the best questions do, because the answer is worth arriving at slowly. For now, it is enough to simply notice the strangeness of it, to feel how odd it is that a universe which could, in principle, have been perfectly still is instead filled from end to end with turning things. The earth beneath you is one of them. So is the sun above you. So is every point of light you have ever traced across a dark sky. You do not need to hold the question tightly. You do not even need to solve it. You need only rest inside the fact of it for a moment, that everything is turning, that it always has been, and that the reason lies somewhere far back in time and very far away, in places and processes we will drift toward gently across this long night. The turning is everywhere. It is patient. It has been going on for billions of years, and it will go on long after this night is over. And bit by bit, we will follow the quiet trail of where it began. Notice, too, that the turning comes in more than one kind, layered one upon another. The Earth spins upon its own axis, giving us the day, and at the same time it circles the sun, giving us the year, and the sun in turn carries it around the center of the galaxy in a far grander loop. You are turning in several ways at once, riding a small, fast turning nested inside a larger, slower one, nested inside a larger, slower one still. It is turning within turning, each wheel set inside a greater wheel, all of it carrying you along together, all of it silent, all of it unfelt beneath your feet. And none of these turnings jostles you or presses upon you, because you are moving along with them, carried smoothly rather than pushed. This is why the turning of the earth cannot be felt, and why for so long people believed the ground was fixed and the sky moved instead. The motion is real, but it is so steady and so shared that it makes no sensation at all. You could stand perfectly still, believing yourself at rest, while beneath and around you several great turnings carry you on at once, none of them announcing itself, all of them older than the ground you stand on. For now, simply let yourself notice the motion that surrounds you without ever touching you. The floor is turning. The sky is turning. The whole slow wheel of the galaxy is turning, and you are riding along inside it, carried without effort, without sound, without the smallest sensation of movement. There is nothing you need to do about any of it. There is only the turning and the question of where it came from, waiting patiently to be answered a little later on. Part 2. The spin that cannot be lost. To understand where all this turning comes from, we have to begin with a simple and stubborn fact about spinning things. Once something is turning, it is remarkably difficult to make it stop. Rotation is not fragile. It does not fade away on its own, the way a sound dies out or a warm object slowly cools. A spinning thing carries a kind of stored motion, and that stored motion behaves almost like a quantity to be guarded. It can be moved from one place to another. It can be spread out or gathered in. It can be handed from one body to a neighbor. But it cannot simply be erased. This stored turning is the quiet rule beneath everything we will explore. Whenever one thing slows its spin, that lost turning does not vanish into nothing. It has to go somewhere. It passes into something else, into another body, into an orbit, into a stream of escaping gas. The books must always balance. And because they must always balance, The turning that fills the universe today cannot have come from nowhere. It must have been present in some form from the very beginning, only waiting to be gathered and concentrated into the worlds and stars we see. There is a familiar image that captures how this gathering works, and it is worth holding on to, because the whole story rests upon it. Picture a figure skater turning slowly on the ice with both arms stretched out wide. Their rotation is gentle and unhurried. Now picture them drawing their arms inward, pulling them close to the body. Without any new push, without touching anything, without any effort beyond the pulling in, they begin to spin faster. The closer they gather themselves, the quicker they turn, until a slow rotation has become a rapid one, all from the simple act of drawing inward. Nothing was added in that moment. No one pushed the skater. The speed did not come from outside. The same amount of turning that was there before, spread across the wide reach of the outstretched arms, was simply packed into a smaller space. And when turning is packed into a smaller space, it has no choice but to quicken. This is the deep principle we will return to again and again tonight. Gather a spinning thing inward, make it smaller, and it must spin faster to preserve the motion it already had. Now take that image and stretch it far beyond a skater on the ice. Imagine the drawing inward happening not across the length of two arms, but across a distance larger than the gap between stars. Imagine a cloud so enormous that light itself would take years to cross it, slowly shrinking, gathering itself down toward the size of a single sun. The same rule applies, only now the effect is enormous, beyond ordinary imagining. A rotation so slow that it takes millions of years to complete a single turn can be concentrated, through that immense shrinking, into a rotation measured in days or hours or less. This is the thread that ties the whole universe of turning things together. The bigger the collapse, the more dramatic the speeding up. A thing that gathers itself down only a little will quicken only a little. A thing that collapses across a truly cosmic span will quicken beyond all ordinary reckoning. And so, as we will see, the most extreme spinners in the universe turn out to be the most extremely collapsed objects, the ones that have been gathered inward the furthest. Their blistering rotation is nothing more than an ordinary, gentle turning, wound to an extreme by the depth of their fall. It helps to sit with what this really means, because it quietly overturns the way we might first imagine spin arising. The turning of a planet was not manufactured when the planet formed. The turning of a star was not created in the moment the star ignited. In each case, the rotation was inherited. It was already present, faint and slow, in the material that came before, and the act of collapsing simply concentrated it, wound it tighter, brought it inward until it became fast enough to notice. The spin is old. It is far older than the objects that carry it now. And this is why the turning cannot simply be switched off, no matter how much time passes. To stop a spinning world, you cannot merely wait for its rotation to fade, because rotation does not fade of its own accord. You would have to take its turning away and give it to something else, and even then, you would only have moved the motion, never destroyed it. The stored spin of the universe is patient and nearly permanent. It shifts and flows from body to body across immense spans of time, but the total is conserved, carried forward endlessly. So keep this rule close as we go on. Everything that turns tonight turns because turning cannot be lost, only gathered, moved, and passed along. The gentle rotation of an ancient cloud becomes the swift rotation of a young star. The rotation of a dying core becomes the frantic spin of the strange, dense object it leaves behind. In every case, it is the same motion, neither created nor destroyed, only concentrated and handed onward. The turning we began with, out there in the earliest clouds, is the same turning that carries the Earth through its days now. It is worth dwelling for a moment on how completely this rule holds, because everyday life seems at first to argue against it. We are used to motion that fades. A spinning coin wobbles and falls. A turning wheel slows and comes to rest. A top winds down and topples. So it feels natural to expect that spin, left alone, should simply die away. But those familiar things slow only because they are handing their turning to something else, to the friction of a table, to the drag of the surrounding air, to the axle they rest upon. The turning is not vanishing even there. It is being passed to the surfaces they touch, bled off into the world around them. Slow it down and follow the motion, and you will always find it has gone somewhere. Out in the emptiness of space, though, there is almost nothing to touch and almost nothing to rub against. A turning thing keeps turning for ages upon ages, its spin bleeding away only through the gentlest and slowest of exchanges. The universe is very nearly frictionless, and so its turning is very nearly eternal. This is why the faint rotation of a cloud, once it has it, is so lasting and so precious. There is nothing out there to stop it. A cloud can drift for ages, turning imperceptibly, and lose almost none of that turning to its surroundings, because its surroundings are very nearly empty. The spin simply waits, conserved, until gravity gathers the cloud inward and concentrates it into something swift. Nothing erased it in the meantime. In the great emptiness between the stars, turning is one of the most durable things there is. We have, then, the shape of an answer beginning to form, though we have not yet reached its source. The turning of the planets and the sun was not made when they were made. It was drawn inward from something that came before, wound tighter by the simple, patient act of falling together under gravity. To find where the spin truly begins, we now have to travel back further still, to the great cold clouds that drift between the stars, and to the faint stirring of motion already waiting inside them. Part 3. The clouds between the stars. The space between the stars is not truly empty. It looks empty to the eye, a plain black nothing stretched between the bright points of light, but scattered through that darkness are enormous clouds of gas and dust, and these clouds are where stars and planets are born. They are among the largest single things a galaxy contains, spanning distances so great that light itself takes years to cross from one side to the other. Inside them lies the raw material for hundreds, sometimes thousands of stars yet to come. These clouds are astonishingly cold and astonishingly thin. If you could scoop up a handful of one, you would find it emptier than the finest vacuum ever made in any laboratory on Earth. And yet the clouds are so enormous that even this thin, scattered material adds up to an enormous total, enough to build whole families of suns. They are quiet places, dark and slow, drifting through the galaxy over spans of time we can barely name. And it is here, in the cold and the dark, that the trail of the turning finally leads us. The most important thing to understand about these clouds is that they are never perfectly still. They drift and they stir. Within them there are gentle currents, slow swirls, great soft eddies of gas moving past one another in every direction. The motion is unruly and complicated, without any single pattern, more like the turning of water in a wide, slow river than the neat spin of a wheel. But out of all that tangled movement, something quietly important almost always survives. There is nearly always a slight leftover imbalance, a faint overall turning of the cloud as a whole. This overall turning is extraordinarily gentle. It is not organized, and it is not fast. A cloud might take tens of millions of years to complete a single rotation, so slow that if you stood within it, you would sense no motion at all, not the faintest hint that anything was turning. And yet that imperceptible, barely there rotation is the seed. It is the ancestor of every spin that will later appear among the stars and worlds this cloud gives birth to. The turning of the future planets is already present here, in the slow stir of the cold, dark gas. There are a few reasons these great clouds are already turning, gently, before anything is born within them. The first is that the galaxy itself is turning, and it does not turn as a single solid wheel. The inner parts of the galaxy circle its center faster than the outer parts, so any large cloud finds one of its edges dragged slightly ahead of the other. This uneven pull gives the whole cloud a slow, ponderous tumble, a rotation inherited directly from the rotation of the galaxy it lives inside. The second reason is the turbulence that fills these clouds. The gas between the stars is endlessly stirred, pushed by the winds of nearby stars, rippled by the shockwaves of distant explosions, disturbed by materials streaming in and streaming out. All this stirring leaves behind swirling eddies at every scale, from small local whirls to slow motions that span much of the cloud. Very few of these swirls cancel each other out perfectly. When they add together across the whole cloud, they almost always leave some small net turning behind. And the third reason is simply that perfect balance almost never happens. Even purely random motion, averaged over something as enormous as one of these clouds, rarely cancels to a perfect and total zero. There is nearly always a little more turning one way than the other, a slight surplus that does not balance out. Genuine stillness, a cloud with no net rotation at all, would be the true coincidence, the unlikely case. Some faint turning is the natural and expected state. And so the clouds drift through the dark, each one carrying its own gentle, inherited spin. Here is the detail that matters most, and it is a subtle one. The starting rotation of these clouds is so slight as to be almost nothing, and yet it holds an immense reservoir of stored turning. This seems like a contradiction until you remember the rule from before. Turning that is spread across a truly enormous space, even if it is very slow, adds up to a great deal of stored motion, precisely because the space is so large. The cloud is turning imperceptibly, but it is turning imperceptibly across a distance light takes years to cross, and that makes all the difference. So the reservoir is there, waiting, hidden inside a motion too gentle to feel. The cloud holds enough stored turning to set an entire star and its family of planets spinning for billions of years, and yet from the inside it would seem utterly at rest. All that is needed to reveal it is for the cloud to gather itself inward, to collapse, to draw its wide, slow turning down into a smaller and smaller space. And when that begins, the faint stir we could never have sensed will wind itself tighter and tighter, until at last it becomes the unmistakable spin of a newborn world. Try, if you can, to picture the strangeness of the scale involved, because it is the key to the whole thing. Imagine a rotation so slow that a single turn takes tens of millions of years, longer than many a mountain range has stood upon the earth. If you watched such a cloud for an entire human lifetime, you would see no change at all, no visible turning, nothing you could point to as motion. And yet spread that imperceptible rotation across a body so wide that light needs years to cross it, and the stored turning within it is immense, a great hidden reservoir waiting in the cold. The slowness fools the eye. The size holds the truth. This is the quiet paradox at the heart of where spin comes from. The gentlest possible motion, spread across the greatest possible distance, holds enough turning to set a star and all its worlds spinning for the whole of their long lives. Nothing about the cloud looks like the fierce rotation that will one day emerge from it. There is no hint, no visible sign, only the slow, dark drift of cold gas. But the turning is there, folded into the immensity, and gravity has only to gather it inward to reveal it. The cloud is like a coiled spring so gently wound that you cannot see the tension in it, holding, all the same, the motion of everything to come. This is where the answer to our question truly begins. The turning of the planets and the sun does not start with the planets and the sun. It starts here, in the cold and the quiet, in the barely moving gas between the stars. Long before there was an earth to turn beneath your feet, there was a slow stir in a dark cloud, and that stir was already, faintly, the beginning of every day and every night you have ever lived. We have found the source. Now we can watch it gather itself inward and quicken. Part 4. The collapse. A cloud between the stars can drift in near balance for a very long time. Its own gravity is forever trying to pull it together, to draw all its scattered gas inward toward a center. But the cloud pushes back against itself, held apart by its own warmth and its own internal motion, and for ages these two tendencies can hold each other in a gentle standoff. The cloud neither collapses nor disperses. It simply drifts, slowly turning, waiting, sometimes for far longer than the entire life of the star it will one day become. But this balance does not last forever. Sooner or later, somewhere inside the cloud, gravity gains the upper hand in a single dense pocket. Perhaps a passing shockwave presses the gas together. Perhaps two clouds drift into one another, or the pressure of light and wind from nearby stars gives the material a squeeze. Or perhaps a region simply grows too heavy over time to hold itself up any longer. Whatever the cause, one part of the cloud crosses a threshold, and its gravity begins to win. That pocket starts to fall inward on itself, gathering toward a center, and the long standoff is over. Once the falling begins, it feeds upon itself. As the gas draws together, its gravity grows stronger, and the stronger pull draws the gas together faster still. What started as a slow settling becomes a genuine collapse, the material tumbling inward across an enormous span of distance, from the scale of a cloud toward the scale of a single star. And all the while, the pocket carries its faint inherited turning with it, wound into the very gas that is falling. It cannot leave its rotation behind. Wherever the gas goes, the turning goes too. And so the skater effect takes hold, on a scale almost beyond comprehension. Remember the rule. Gather a turning thing inward, make it smaller, and it must spin faster to keep the motion it already had. Now the gathering is not the length of two arms, but the collapse of a cloud light years across, shrinking down toward the size of a sun. The gentle rotation that once took tens of millions of years to complete a single turn is wound tighter and tighter as the gas falls, quickening through the long descent, until it is turning thousands upon thousands of times faster than it did before. Picture the spring that gravity had been slowly loading all those ages, and imagine it finally released, not outward, but inward. The cloud pours itself down toward its own center, and as it pours, it spins up. Each stage of the shrinking adds to the speed, because at every stage the turning is being packed into a smaller space, and the smaller the space, the faster the spin. There is no push, no outside force winding the cloud up. There is only the falling, and the falling alone is enough to transform a barely moving cloud into a rapidly turning core. The range of this shrinking is difficult to hold in the mind. The gas begins spread across a distance so great that light needs years to cross it, and it ends gathered into a body you could, in principle, orbit in a matter of hours or days. Across that entire, tremendous descent, from the widest scale to the narrowest, the rotation never stops increasing. The turning has nowhere to go but faster, because it cannot be lost, and because the space it occupies keeps shrinking. Every mile the gas falls inward is another turn of the winding spring. By the time a recognizable young star begins to take shape at the center, along with the material that surrounds it, the once imperceptible turning has become the dominant motion of the whole system. What could not be felt at all in the drifting cloud is now the defining feature of the newborn arrangement of gas. The slow stir has become a true spin. And this spin will shape everything that follows, deciding the very form the young system takes, the flat and orderly architecture that will one day hold a family of planets in nearly a single plane. It is worth pausing on how quietly extraordinary this is. Nothing was created. No motion was invented. The turning of the young core is precisely the turning the cloud always had, merely concentrated by the fall. And yet the difference in appearance is total. A cloud that seemed perfectly still has become an object visibly, rapidly spinning, and it did so through nothing more dramatic than gathering itself together under its own weight. The stillness was never real. It was only slowness, spread thin across an immense space, and collapse revealed the truth of it. So we can now see the shape of the whole answer laid bare. The turning of a star begins as the faintest stir in a cold cloud. Gravity, over ages, tips that cloud into collapse. And the collapse itself, by drawing the turning inward, winds it up into a real and rapid spin. No hand set the top going. The gas set itself going, simply by falling together, obeying the rule that turning must quicken as it gathers. The spin of every young star in the universe is written in that single sentence. But a collapsing, spinning cloud does not simply become a spinning ball and stop there. The turning does something more to it, something that shapes the entire future of the system and explains one of the most striking features of every solar system we have ever seen. The rotation forces the falling gas into a particular shape, a flat and spreading form, and it is to that shape and to the birth of the disk that we turn next. Part 5. Why solar systems are flat. When you picture a solar system, you might imagine a ball of planets scattered in every direction around a central star, some circling high above, some far below, filling a great sphere of space. But that is not how solar systems are built. They are flat. The planets of our own system all travel around the Sun in nearly the same plane, like marbles rolling on a single wide table, rather than swarming around it in a cloud. This flatness is not an accident, and it is not a small detail. It is one of the deepest fingerprints of rotation, written into the very shape of the system. The reason traces directly back to the collapse we followed in the last part. A cloud that is falling inward, and also turning, cannot fall inward evenly in every direction. The turning gets in the way, but only in certain directions, and this uneven resistance is what flattens the whole system into a disk. To see how, it helps to think about the axis the cloud is turning around, the imaginary line running through its center, like the axle of a wheel. Along that axis, and out along the wide circle of the turning, the gas behaves in two very different ways. Consider first the direction along the axis, toward what we might call the poles of the cloud, the top and the bottom. In these directions, the gas feels very little of the rotation. There is nothing to hold it up, and so it falls almost straight inward, dropping freely toward the center. This causes the cloud to flatten from above and below, its height shrinking as the polar gas pours in. Top and bottom collapse readily, pressed together as the material falls toward the middle plane. Now consider the other direction, out along the equator, in the direction of the turning itself. Here the story is completely different. The gas in this direction is moving, carried around by the rotation, and that motion resists the inward fall. It is the same reason a ball swung in a circle on a string resists being pulled straight to your hand. The turning holds the gas up, keeps it from falling all the way in, so that it cannot reach the center. Instead, it settles into a wide, spreading, rotating sheet, held out at a distance by its own motion. Put those two behaviors together, and the shape becomes inevitable. The gas along the poles falls in and flattens the cloud, while the gas along the equator is held out and spread wide. What began as a roughly round, collapsing cloud becomes a flattened, turning disk, thin from top to bottom and broad across its face, with the young star growing at its dense and heavily fed center. This flattened, spinning disk is the birthplace of planets. Everything that will become a world forms within it and inherits its single shared direction of turning. This is why the planets of a solar system orbit in nearly the same plane and travel in the same direction around their star. They were all shaped from the same spinning sheet, and they carry the memory of that sheet in their orbits. The flatness of a solar system is nothing less than a fossil of the rotation of the cloud it came from, preserved for billions of years in the arrangement of its worlds. When you see the planets strung out along a single plane, you are looking at the frozen record of an ancient turning. There is something quietly beautiful in this, and it is worth letting it settle. A solar system is not a random scattering of worlds thrown out in all directions. It is an orderly thing, a set of planets gliding the same way around the same center, lying almost in a single flat plane, and every part of that order comes from the turning of the cloud that made it. Look at the flatness, and you are looking at the shape of a rotation older than the star itself. The disk remembers the cloud. The planets remember the disk. And the disk does more than simply set the plane of the orbits. It is an active living place while it lasts, a great turning reservoir of gas and dust through which material spirals slowly inward toward the growing star, feeding it, building it. The disk is where the rotation of the whole system is stored and worked upon, passed from region to region, concentrated here, spread out there. It is within this turning disk that the next chapters of our story unfold, both the strange puzzle of the star that ends up spinning slowly and the way the planets themselves come to turn. It is worth noticing how deeply this single shape has stamped itself on the sky, because once you know to look for it, you find it nearly everywhere. The rings that circle certain planets lie flat, in a single thin plane, for the very same reason a solar system does, gathered from the spinning debris around a world. The great disks of the galaxies are flat in the same way, immense wheels of stars pressed into a thin plane by their own turning. Wherever gravity gathers a spinning collection of matter, the result is a disk, thin through its middle and broad across its face. The flatness is the signature that turning always leaves behind, written at every scale from a ring around a planet to a galaxy of 100 billion suns. And the disk is not a still and finished thing while it lasts. It is alive with slow motion, gas and dust drifting inward through it, spiraling gradually down toward the growing star at its center, feeding it grain by grain. The turning holds the material out at a distance, and yet, little by little, that material still finds its way inward, giving up its rotation to the regions farther out, so that it can fall at last onto the star. So the disk is both a cradle and a conveyor, holding the young worlds in their orbits while slowly delivering matter to the star it surrounds. Everything that will become a planet is drifting somewhere within this turning sheet, waiting to be gathered. For now, hold the image of the disk in your mind, flat and wide and slowly rotating, glowing faintly around a young star at its heart. Nearly every solar system in the universe passed through this same shape on its way to being born, including our own. The Earth beneath you, the other planets you know by name, the sun that lights your days, all of them were shaped within such a disk, long ago, out of a cloud that had done nothing more remarkable than fall together while it gently turned. The flatness of your own sky above the plane of the planets is the last echo of that turning cloud. Consider what a strange transformation this collapse really performs upon time itself. Before it begins, the cloud lives at the slowest imaginable pace, one turn in tens of millions of years, a rhythm so ponderous it barely deserves the name of motion. After the collapse has run its course, the young core may turn in a single day, or faster. The very tempo of the thing has been transformed. quickened by an enormous factor, and yet not one push was applied from outside to hurry it along. The whole acceleration came from the falling, from the simple geometry of a turning thing drawn inward. Gravity did not spin the cloud up directly. It only pulled it together, and the spinning up followed on its own. There is a kind of patience in this that is worth admiring. Gravity works slowly, gathering the cloud across ages, and for most of that time the turning quickens only gently, because the cloud is still enormous and the gathering still gradual. It is near the end, when the material has fallen far and the remaining distance is small, that the speeding up becomes most dramatic, the rotation winding up quickly in the final stages of the fall. Like the skater who spins fastest in the last moment of drawing the arms fully in, the collapsing core saves its most rapid turning for the end. The long, slow gathering sets the stage, and then, in the final closing in, the true spin is revealed. We have watched the cloud collapse and flatten into a spinning disk. We have seen why solar systems are flat and why their worlds all move the same way. But now we come to one of the strangest and most quietly surprising parts of the whole story. For if the collapse simply concentrated the turning inward, then the young star at the center ought to be spinning tremendously fast, far faster than any star we actually see. And yet, it is not. Somewhere, most of that turning is taken away from the star. Where it goes is a genuine puzzle, and it is where we turn next. Part 6. The Star That Gave Its Spin Away. Here the story reaches its most interesting complication and one of its gentlest, genuine mysteries. We have followed the turning all the way down, from the faint stir of the cloud to the winding up of the collapse. And if that were the whole story, if collapse simply concentrated the rotation inward without anything interfering, then the young star at the center should be spinning at a truly ferocious rate. It should be turning so fast that it could scarcely hold itself together, flinging its own material outward, unable to settle into a stable star at all. But real stars do not do this. They spin far more slowly than that simple picture would predict. Our own sun turns in a leisurely way, roughly once a month, nowhere near the frantic pace the raw inheritance of the collapse would suggest. Somewhere along the way, most of the spin that should have ended up in the star was taken from it, drained away and handed off elsewhere. The question is where it went, and the answer is one of the quietly unresolved puzzles of how stars are born. The turning did not disappear, because turning cannot disappear. It was moved. But following exactly where it moved, in every case, is difficult. Our own solar system shows the puzzle in its plainest and most striking form. Think about where the matter is. The sun holds almost all of it. Beside the sun, the planets are barely more than a rounding error, a scattering of small bodies around an overwhelming central mass. If turning simply followed matter, the sun should carry almost all the rotation of the system as well. But when you tally up where the turning actually resides, the accounting flips almost completely. The sun, for all its mass, holds only a small share of the total spin. The great majority is carried not by the star, but by the planets, gliding in their wide, slow orbits. And most of that planetary turning is held by a single world, the largest of them, out in its great distant circle. This is a genuinely strange arrangement, and it is worth sitting with. The body that holds nearly all the mass ended up with almost none of the turning, while a handful of comparatively tiny worlds ended up carrying nearly all of it. The star kept the matter and gave away the motion. It is as if a great heavy wheel handed its spin to the small pebbles orbiting around it, and then slowed almost to a stately crawl. This is the fingerprint of whatever took the spin away. So how does a young star shed its turning? Several gentle mechanisms seem to work together, each one carrying a little of the rotation outward, away from the star and into its surroundings, and together They keep the star from spinning itself apart. The first involves the star's magnetism. A young star has a powerful magnetic field, and that field reaches out and links the star to the surrounding disk of gas. These magnetic connections act at once like a soft brake and like a leash, dragging on the star's rotation and passing its turning outward into the slower material beyond. The second mechanism is more dramatic. Young stars fling great streams of material away from themselves, out along their poles, hurling gas outward into space in long, narrow jets. This escaping material does not leave quietly. It carries turning away with it, draining rotation from the star as it departs, like a spinning skater flinging weights off into the distance and slowing as they go. Every stream of gas thrown outward takes a share of the spin along with it, and over the long berth of the star, this steadily bleeds away much of the rotation the collapse had concentrated. The third mechanism continues quietly for the rest of the star's life. Even a settled, mature star sheds a steady wind of particles into space, a soft and constant breeze streaming outward in every direction. The star's magnetic field guides that wind far out before it lets it go, and each escaping gust carries away a tiny amount of rotation. Turn by turn, age by age, this gentle wind slows the star, so that over billions of years it spins ever more slowly, braked continuously by its own quiet breath. The slowing is imperceptible in any single moment, but relentless across the long stretch of a stellar lifetime. And within the disk itself, turning is passed steadily outward as well. The inner material sheds its rotation to the regions farther out, and having lost its spin, it can finally spiral down onto the growing star. Meanwhile, the turning it gave up migrates outward, into the distant parts of the disk where the planets are forming, and settles into their orbits. This is part of why the planets carry so much of the system's rotation today. They were handed the spin that the inner disk and the star had to give away in order to come together at all. So the calm, slowly turning sun we know is not the natural result of a simple collapse. It is what remains after most of the inherited spin has been carried outward, to the jets, to the wind, to the magnetic threads, and finally to the planets that still hold it. The star gave its turning away in order to become a star at all. It kept the fire and the mass, and passed the motion outward to its children. And exactly how the books balance in every young star, exactly how much goes where, remains an open and quietly beautiful question that has not been fully answered. There is a quiet irony worth savoring in this arrangement, and it deepens the puzzle rather than resolving it. The star gave its turning away in order to exist at all. Had it kept the full inheritance of the collapse, it could never have settled into a stable, steady sun. It would have been undone by its own spin before it could shine. So the very act of shedding rotation was what allowed the star to become a star, calm enough to burn quietly for billions of years. The turning had to be surrendered for the light to be born, and the planets that carry that surrendered turning are, in a sense, the price the star paid for its own stability. And this may be part of why planets exist at all in the way they do, gathered in a flat and orderly disk. The same outward handing of rotation that let material spiral down onto the star also spread the turning into the outer regions, where it settled into the orbits of the forming worlds. The planets did not merely happen to end up with the spin. They may hold it, because holding it was part of how the whole system came together, the outer disk taking up the rotation the inner regions had to release. The strange division of matter and motion between the sun and its worlds is not a flaw in the story. It may be one of the conditions that made the story possible. Let us gather up where we have come, before we go on, because the trail has wound a long way. The turning began as the faintest stir in a cold and enormous cloud. Gravity tipped that cloud into collapse, and the collapse wound the turning tighter, concentrating it inward. The spinning, falling gas flattened into a disk, setting the flat plane of the whole system. And then, strangely, the young star at the center gave most of its turning away, handing it outward to jets and wind, and to the planets forming in the disk around it. That is the story so far. Now we can follow the turning into the planets themselves, and see how each world came to spin. Part 7. How the planets got their spin. Within the turning disk, the planets assemble slowly, from the bottom up. It begins with the finest grains of dust, drifting through the gas, occasionally bumping into one another and sticking. Small clumps grow into larger ones. Pebbles gather into boulders, boulders into bodies large enough to pull on their neighbors with their own gravity, and those bodies sweep up more material still, growing at last into worlds. Every stage of this building takes place inside the disk, and the disk is turning, and so everything that forms within it inherits that turning as its birthright. Because all the material in the disk shares one common direction of rotation, the growing planets inherit that direction too, both in the way they travel around the star and in the way they spin upon their own axes. As a young planet sweeps up the gas and dust around it, most of what it gathers is already moving in the disk's shared direction. That material carries its motion onto the planet, and so the planet tends to end up turning the same way the disk turns, which is the same way it orbits. This shared direction, the natural default, is the one astronomers call prograde, and it is why most planets spin the same way, and spin the same way they travel. So the general tendency is clean and orderly. The disk turns one way, and the planets, built from the disk, mostly turn that same way as well. When you look at the solar system, and notice that most of its worlds rotate in the same direction and orbit in the same direction, you are seeing the disk's rotation remembered once more, now at the scale of individual planets. The same ancient turning that flattened the whole system into a plane has also set most of its worlds spinning in step, each one a small echo of the great disk that made them. But a planet's exact spin is a far messier inheritance than its orbit, and this is where individual character enters the story. The direction of a planet's orbit is set cleanly by the disk and rarely disturbed. But how fast a planet turns, and the precise tilt of its axis, are shaped by something far more chaotic. In the final stages of building a world, growth happens through enormous collisions, as large bodies crash together and merge. And a single great impact, striking off-center near the end of a planet's formation, can dramatically change how that world spins. Such a collision can speed a planet up or slow it down. It can tip the axis over, tilting the world so that it leans at a steep angle. In rare cases, it can even overturn a planet almost completely. So while the gentle prograde tendency comes from the orderly disk, the fine details of each planet's spin, its speed and its tilt, are written by the luck of its last violent collisions. This is why the planets, though they mostly turn the same general way, do not all turn at the same speed, and do not all sit at the same angle. Each carries the marks of its own particular history. It helps to hold these two influences side by side, because together they explain nearly everything about how worlds turn. On one hand, there is the orderly inheritance from the disk, which gives the planets their shared direction, their common prograde spin and prograde orbits. On the other hand, there is the chaos of the final impacts, which scatters the exact speeds and tilts, making each world a little different from its neighbors. Order sets the pattern. Chance decorates the details. And between the two, the whole variety of spinning worlds is accounted for. This is why our own world turns once in about a day, at a comfortable and familiar pace, while the giant planets whirl around in only a handful of hours, and other worlds turn far more slowly still. It is why some planets stand nearly upright as they spin, their axes only gently tilted, while others lean at steep and dramatic angles, giving them seasons far more severe than our own. None of this was assigned deliberately. It emerged from the same two forces at work in every case, the orderly disk and the chance of the final collisions, playing out a little differently for each world. So the turning of the planets, like the turning of the star, was inherited rather than created. It came down from the disk, which came down from the collapse, which came down from the faint stir of the cloud. At every step, the same motion was passed along and reshaped, never made from nothing, never truly lost. The spin of the earth beneath your feet is the spin of the ancient cloud, handed down through the disk and settled at last into the steady rhythm of your days and nights. It is a very old motion, wearing the shape of something ordinary. The moons of the planets carry this same inheritance, in their own smaller way. Many of the large moons formed within little disks of their own, rings of gas and debris that gathered around the giant planets, much as the great disk gathered around the young sun. And so those moons, too, tend to circle their planets in the direction of the disk that made them, and to lie in a common plane, small echoes of the same flattening that shaped the solar system as a whole. The pattern repeats itself down the scale, a disk around a star, a disk around a planet, each one printing its shared turning onto the bodies born within it. This is why, when we look closely, the solar system reveals a kind of nested orderliness. The planets circle the sun the same way, in nearly one plane, because they came from one disk. Many moons circle their planets the same way, in nearly one plane, because they came from smaller disks in turn. The turning is inherited again and again, at every level, each spinning sheet handing its direction down to its children. And against that deep order, the exceptions stand out all the more sharply, the few worlds and moons that turn the wrong way or lean at strange angles, each one marking a place where some rare event reached in and overruled the tidy inheritance of the disk. Now that we understand how the planets came to turn, and why they mostly turn the same way, we can look more closely at the worlds themselves. We can move among them, one by one, and listen to the different rhythms of their turning, the swift whirl of the giants, and the slower pace of the smaller worlds. And then we can turn to the exceptions, the two worlds in our own system that break the orderly rule, and see what strange histories were needed to make them turn the way they do. Part 8. A Tour of Turning Worlds. Now that we understand where the turning of the planets comes from, we can move gently among the worlds themselves and listen to the different rhythms of their spin. Against the shared background of the disk, each planet keeps its own pace, its own length of day, and the pattern that emerges across the solar system is quietly revealing. Some worlds whirl around in only hours. Others take far longer to complete a single turn. And the differences are not random noise. They carry a record of how each world was built and of how the sun has pulled upon it ever since. Begin with the giants, the great outer worlds, for they turn the fastest of all. The largest planet in the solar system, despite its enormous size, completes a full rotation in only about 10 hours. This is a remarkable thing to hold in the mind. A world so enormous that it could swallow all the others many times over, nonetheless spins around faster than the Earth does, wrapping through an entire day and night in less than half the time our own world takes. Its great size does not slow it. If anything, it emphasizes just how much turning was gathered into it as it formed. That swift rotation leaves a visible mark upon the planet. Spinning so quickly, the great world bulges outward at its equator, its middle swept out by the speed of its own turning, so that it is measurably wider across its waist than it is from pole to pole. It is not a perfect sphere, but a slightly flattened one, squeezed by its own spin into a gently swollen shape. And the rapid turning helps drive the banded clouds that wrap the planet, drawing its weather out into long parallel stripes and feeding the great slow storms that circle within them for ages. The great ringed planet, next outward, turns nearly as fast, completing its own day in only about 10.5 hours. It is the most flattened of all the planets, its swift rotation pulling its equator out into a shape noticeably squashed, its poles visibly closer to its center than its bulging middle. Here, the fingerprint of turning is written most plainly of all. You could measure the speed of the planet's spin simply by looking at how far its equator has been swept outward, how much the turning has reshaped the whole globe. The rings that circle it lie exactly in the plane of that turning, a flat, bright echo of the planet's own rotation. The two outer giants beyond them also turn quickly, each completing a rotation in something under a day. Their fast spin stirs deep winds through their cold atmospheres, driving currents of gas around the worlds at tremendous speeds. Across all four of these giant planets, the pattern holds firm. The large outer worlds, gathered from more material farther out in the disk, spin fast, carrying a generous share of the turning the disk had to give. Their swift rotation is a sign of how much motion was concentrated into them during their formation. Turn now to the smaller worlds closer in, and the rhythm slows. Our own Earth completes a rotation in about a day, a pace so familiar that we simply call it the day itself. The steady procession of morning and evening, of light and dark, and light again, is nothing more than the Earth turning beneath the sun, carrying each part of its surface into the light and then away from it. It is a comfortable, moderate pace, neither the whirl of the giants nor the crawl of the slowest worlds, and life on the planet has grown up entirely within its gentle rhythm. The red planet next door turns at almost exactly the same pace as the Earth, completing its day in a little over our own 24 hours. Its day is a close cousin of ours, so near to it that a visitor might scarcely notice the difference. This is a quiet coincidence of the two worlds' separate histories, their spins settling by chance into nearly the same rhythm, though they were built from different parts of the disk and struck by different collisions along the way. Two neighboring worlds, turning to almost the same beat, for no reason deeper than the luck of how each came together. The small innermost planet, closest to the sun, tells a very different story. It turns very slowly, and it is caught in a gentle mathematical lock with its own orbit. For every 2 journeys it makes around the sun, it rotates exactly 3 times, its spin and its orbit bound together in a tidy ratio. This rhythm was set by the steady pull of the sun upon its nearest world, tides tugging at the little planet over immense spans of time until its turning settled into step with its path. It is a first sign of something we will explore more fully soon, the way the tides between 2 bodies can reshape and capture a world's spin. Step back, and the broad pattern across the solar system becomes clear. The giant planets, formed farther out and gathered from more material, spin fast and wear the flattened shapes their turning gives them. The smaller inner worlds, closer to the sun and worked upon harder by its tides, tend to turn more slowly. Rotation across the whole family of planets is a record of 2 things at once, of how each world was built out in the disk and of how the sun has been tugging on it ever since. The length of a planet's day is a small history of the planet itself. And notice, as we drift among these worlds, how much of what we assumed was fixed turns out to be inherited and reshaped. The day is not a universal unit set by some outside clock. It is different on every world, decided by the turning each planet was given and by everything that has happened to that turning since. A day of 10 hours on a giant, a day close to our own on the red world next door, a day stranger than a year on the world we will soon meet that breaks every rule. Each is the same ancient motion, worn into a different rhythm by a different history. There is something quietly wonderful in the fact that a planet's spin can be read from its very shape. A world that turns quickly is swept outward at its equator, bulging at the middle, flattened at the poles, and the faster it turns, the more pronounced this swelling becomes. So the shape of a planet is a kind of frozen record of its rotation, a fingerprint you could measure from a great distance without ever timing a single day. The great flattened giants wear their swift turning openly, their squashed globes announcing their speed. A more upright, rounder world turns more gently. The turning writes itself into the form, and the form remembers the turning. And the length of a day, too, is a kind of quiet biography of each world. It records how much turning the planet gathered as it formed, out in its part of the disk. It records the great collisions that sped it up or slowed it down near the end of its building. And it records the long ages of tidal pulling from the sun, which has been gently working on the inner worlds since they were young. No two of these histories are quite the same, and so no 2 days across the solar system are quite the same either. Every world keeps its own time, and that time is the sum of everything that has ever happened to its spin. We have moved among the orderly worlds, the ones that inherited their turning cleanly from the disk and kept it more or less in the expected way. Their spins vary in speed and in tilt, but they all turn in the same general direction, the direction of the disk that made them. They are the rule. But there are exceptions, worlds whose turning breaks so sharply from the pattern that they demand a special explanation, and those exceptions are among the most telling stories in the whole solar system. It is to those rule breakers that we turn next. Part 9. The worlds that break the rule. If nearly everything inherits its turning from the same spinning disk, then the exceptions become the most revealing stories of all. Each one required something unusual to happen, some rare event powerful enough to override the orderly inheritance and turn a world against the pattern of its siblings. And in our own solar system there are 2 great rule breakers, 2 worlds whose spin is so strange that it stands as a puzzle even now. They are worth lingering on, because in defying the rule, they show us just how strong the rule really is. The first of these is the world that turns backward. Nearly every planet spins in the disk's common direction, the same way it orbits the sun, the direction we have followed all through this story. But one world rotates the wrong way, against the grain, turning in the opposite sense from almost all its neighbors. If you could stand upon it and watch the sky, the sun would rise where on other worlds it sets, moving across the heavens in the reverse direction. This alone would make the planet strange. But its rotation is stranger still, because it turns so slowly. This backward-turning world spins so gently that a single one of its days lasts longer than its entire year. Think about how remarkable that is. The planet completes a full journey around the sun before it can finish even one turn upon its axis. Its day outlasts its year. It turns so slowly that the very idea of a day upon it stretches almost past meaning, a single sunrise separated from the next by more time than the world needs to circle the sun completely. Everything about its rotation is the opposite of what the orderly disk would have given it. Both the direction and the pace turn strange. How did it come to spin this way? There is no settled answer, and this is one of the genuine open puzzles of how worlds get their turning. One possibility is that the planet was struck long ago by a colossal impact, a collision so violent that it overturned the world, flipping its rotation into reverse. Another possibility looks not to a single sudden blow but to a slow and patient process. The planet is wrapped in a thick and heavy atmosphere, and that dense air may have acted upon it like a slow tide over immense stretches of time, gradually breaking its original spin, stopping it, and easing it around into a backward turn. Both of these explanations are argued, and neither is certain. It may even be that some mixture of the two is closest to the truth, a great impact and then long ages of atmospheric breaking together, shaping the world's strange rotation. What matters for our story is the lesson the puzzle carries. To make a world spin backward against the direction of the disk that made it took something extraordinary, whether a catastrophic collision or an age of patient tidal slowing. The orderly turning is so deeply the default that overturning it required a genuine upheaval. The second great rule breaker does not turn backward, but it does not turn upright either. It lies on its side. Where almost every world spins more or less upright as it circles the sun, its axis pointing roughly up and down, this planet is tipped so far over that it rolls around its orbit on its side, its poles pointing nearly along its path rather than above and below it. It is as though a spinning top had been knocked flat and kept turning, lying down, tracing its circle around the sun while pointing sideways the whole way around. This extreme tilt gives the world the strangest seasons of any planet. Through its long journey around the sun, first one pole and then the other is aimed almost directly at the light. For a great stretch of its year, one pole bakes in continuous day, while the other is buried in continuous dark. And then, slowly, the situation reverses. The seasons are not the mild rhythm we know, but something far more severe. Whole poles turn toward the sun and then away, the planet nodding through extremes as it rolls along on its side. It is a world whose very orientation defies the tidy, upright spin of its neighbors. The leading explanation is much like the first cause we considered for the backward world. Early in its life, the planet is thought to have suffered one or more giant collisions, blows so powerful that they knocked it over, tipping its axis further and further until it fell nearly flat. As with the backward-turning world, the exception is best understood not as a different rule, but as the ordinary rule, interrupted by an extraordinary event. The disk gave this world its turning in the usual way, and then a catastrophe reached in and tipped that turning onto its side. This tipped-over world has been the subject of an earlier evening on this channel, and it is worth remembering here as a companion to its backward-spinning sibling. Taken together, these two rule breakers carry a quiet reassurance, and it is the same reassurance that runs beneath the whole story of cosmic turning. The rule that everything inherits its spin from the disk is strong. It is so strong that defying it takes a genuine catastrophe, a colossal impact, or an age of patient tidal breaking, nothing less. The orderly turning is the default, the natural outcome, the thing that happens unless something enormous intervenes. The exceptions are not signs that the rule is weak. They are the rare marks left where overwhelming history managed, against the odds, to override it. And notice what the exceptions share with the ordinary worlds beneath their strangeness. Even the backward world is still turning. Even the world tipped on its side is still spinning as it rolls. The catastrophes that struck them did not stop their turning, only redirected it, tilted it, reversed it. The motion itself endured, because turning is not easily destroyed, only moved and reshaped. In the strangest worlds, as in the ordinary ones, the ancient inheritance of the cloud is still there, still turning, merely wearing a stranger face. The rule breakers are not confined to the planets either. Among the many moons of the solar system, there are a few that circle their worlds the wrong way, turning against the direction of all their neighbors. These backward-orbiting moons are thought not to have formed alongside their planets at all, but to have been captured from elsewhere, drifting in from the surrounding space and caught by a world's gravity into a reversed path. They did not inherit their motion from the local disk, and so they do not share its direction. Like the backward-turning planet, they are exceptions that prove how strong the ordinary inheritance is, for it took an outside origin to make them move against the grain. Each of these strange cases tells the same underlying story from a different angle. The orderly turning of the disk is the rule, deep and reliable, and it governs nearly everything born within a forming system. But now and then something intrudes upon that order, a giant collision, a slow atmospheric tide, a wandering body captured from outside, and the result is a world or a moon that turns against the pattern. We do not need a new rule to explain these oddities. We need only the old rule, plus the record of some rare and powerful event that reached in and overruled it. The exceptions are history made visible, the marks of upheavals long past. These rule breakers also introduce, quietly, the next great theme of our story. For one of the ways to make a world spin strangely, we saw, is not a sudden impact, but a slow tidal breaking, the patient pull of one body upon another over immense stretches of time. That slow tidal process is not rare or exceptional at all. It is at work everywhere, quietly reshaping the turning of worlds and moons across the whole solar system, and it is at work upon our own Earth this very night. It is to the tides and to the slow giving away of spin that we now turn. Part 10. Spin given away. Tides, slowing, and locking. Rotation, once a world has it, does not stay fixed forever. It can be slowly bled away over immense stretches of time. But because turning cannot simply vanish, whenever one body loses some of its spin, that lost turning has to be handed to something else. It is never destroyed, only transferred, passed from a rotation into an orbit, or from one body into another. And the great agent of this slow exchange, quietly at work all across the solar system, is the tide. To see how a tide can steal a world's spin, picture two bodies orbiting close together, a planet and its moon, or a world and its star. Each one raises a gentle bulge upon the other, a slight stretching of the body along the line that joins them, drawn out by the difference in the pull of gravity across its width. The near side is tugged a little more than the far side, and so the whole body is stretched, ever so slightly, into a shape a touch longer along that line. This stretching is the tide, and though it is small, it is the lever by which turning is moved. Now let the stretched body turn. As it rotates, it carries its bulge along with it, sweeping the raised region a little ahead of the line joining the two bodies, because the rotation is faster than the slow circling of the orbit. So the bulge is dragged forward, out of perfect alignment, and the gravity of the companion pulls back upon that slightly misplaced bulge, tugging against the direction of the spin. Turn by turn, this backward tug acts as a soft and endless brake, gradually slowing the rotation. And the turning that is lost passes outward into the orbit of the companion, pushing the two bodies slowly farther apart. Our own world is living through exactly this process, right now, tonight. The moon raises tides upon the Earth, and those tides are very gradually slowing the Earth's rotation, lengthening our day by a tiny amount over long ages. The change is far too small to notice in a lifetime, or in many lifetimes, but it is real and it is steady. In the deep past, the Earth turned much faster than it does today. Its day was only a handful of hours long, the sun racing across the sky, the world whirling far more quickly than the gentle rhythm we know now. Over billions of years, the moon's patient tides have stretched that short day out toward the day we live by. And the spin the Earth loses is not destroyed. It is handed to the moon's orbit, which is precisely why the moon is drifting slowly outward, moving a little farther from the Earth with each passing age. The Earth turns a little slower, the moon climbs a little higher. The turning has simply moved from the spin of one body into the orbit of the other, the books balancing exactly, motion neither made nor lost, only passed along. If this slow breaking runs all the way to its natural conclusion, it reaches a quiet and elegant endpoint. Eventually a body turns exactly once for each time it circles its partner, and once that happens, the tide no longer sweeps ahead, and the breaking ceases. The body has settled into perfect step, always keeping the same face turned toward its companion. This is called tidal locking, and it is not a rare oddity. It is one of the most common arrangements in the whole solar system, the natural resting place toward which the tides are forever nudging. Our own moon has already reached this endpoint. It is tidally locked to the Earth, turning exactly once for every circle it makes around us. And this is why it forever shows us a single face and keeps the other hidden. The moon is not still. It is turning steadily, once each orbit, but its turning is so perfectly matched to its circling that the same familiar face greets us night after night, age after age. What looks like a moon that does not rotate is in truth a moon whose rotation has fallen into perfect step with its path. Its turning has come to rest without ever stopping. The same locking has claimed moons all across the solar system. Most of the large moons of the giant planets are tidally locked to the worlds they circle, each keeping one face turned inward toward its planet, and the other turned forever out toward the dark. And we have already met a gentler cousin of this arrangement, the innermost planet, which rather than locking completely settled into a tidy rhythm of 3 turns for every 2 orbits, held in that ratio by the sun's tides and the shape of its own slightly stretched path. Locking and resonance are simply different resting places the tides can find. There is one arrangement more perfectly balanced still, out at the cold far edge of the solar system, where a distant small world and its largest moon have locked not just one of them to the other, but each to each. The world shows only one face to its moon, and the moon shows only one face to the world, the two of them turning in perfect mutual step, each forever presenting the same side to its partner. It is the most complete version of this slow surrender, both bodies caught together in a single shared rhythm, turning endlessly, but never again changing what they show one another. It is worth being clear about what tidal locking really means, because it is easy to mistake it for the turning coming to an end. Locking is not the death of rotation. It is rotation reaching a quiet equilibrium, a place of rest that is still, in truth, a place of motion. The locked moon still turns. The locked worlds still spin. Their turning has simply fallen into perfect step with their orbits, and there it can stay, undisturbed, for the rest of the body's long lives. The tide does not stop the spin. It guides it, patiently, into balance. If we follow the Earth and the Moon far enough into the future, the slow exchange between them points toward a distant destination. As the Earth keeps turning a little slower and the Moon keeps drifting a little farther away, the two are creeping, across immense spans of time, toward a deeper balance. Given long enough, the Earth's day would stretch until it matched the Moon's slow circling, and the world would keep one face turned always toward its companion, the same way the Moon already keeps one face turned toward us. Whether the wider workings of the solar system ever allow that final state to be reached is another matter, but the direction of the drift is clear. The tide is forever nudging the pair toward a shared and settled rhythm. There is a gentle lesson in watching this unfold so slowly. The tides do not wrench or hurry. They work by the smallest of tugs, repeated turn after turn, age after age, and only across billions of years do those tiny pulls add up to something as profound as a lengthened day or a receding moon. It is patience made physical, a reshaping so gradual that no single generation could ever witness it, and yet utterly certain over the long reach of time. The turning of a world is not fixed and eternal. It is slowly negotiated over ages between a planet and everything that pulls upon it, and the outcome is written far too slowly for any eye to catch. And so the tides reveal something gentle about the whole story of cosmic turning. Even when a world's spin is slowed, even when it is bled away over billions of years, the motion is never lost. It only moves from a rotation into an orbit, from one body into another, always conserved, always accounted for. The Earth slows, and the Moon drifts outward. A moon locks and keeps on turning in step. Everywhere the tides are at work, they do not erase the turning of the universe. They only carry it, slowly and patiently, from one form into another. Now we can lift our eyes from the worlds to the stars and see how the same slow giving away of spin plays out in the lives of the suns themselves. Part 11. How stars grow old and slow. Stars, like planets, do not keep their birth rotation unchanged across their long lives. A star is born spinning relatively quickly, carrying a generous share of the turning left to it after all the shedding of its formation. And then, across the immense span of its life, it gradually slows, winding down a little more with every passing age. This slow breaking of a star reveals something quietly telling about it, for the pace at which a star turns is bound up with its age and even with its temperament, the character of its surface and its light. Consider our own star first, because it shows the pattern plainly. The sun turns roughly once a month, a stately and unhurried rotation. But it does not turn the way a solid ball turns, all of one piece, because it is not solid at all. It is an enormous sphere of hot, glowing gas, and different parts of it turn at different speeds. Its equator sweeps around faster than its higher latitudes, so that the bright bands nearer its middle complete a turn more quickly than the regions nearer its poles. The whole star is turning, but it is turning unevenly, its layers and zones sliding past one another as they go. This uneven differential rotation is not a small curiosity. It has consequences written across the face of the sun. Because different parts of the star turn at different rates, the sun's magnetic field is slowly wound up over time, stretched and twisted by the sliding of one region past another. And that winding of the magnetic field is closely tied to the rhythm of the sun's activity, to the dark, cooler patches that come and go upon its surface, and to the flares and eruptions that rise from it. The visible weather of the sun, its spots and its storms, is bound up intimately with the way the star spins. So the turning of a star is not a hidden or abstract thing. It shapes the star's surface, drives its magnetism, sets the rhythm of its activity. A star that turns quickly winds its magnetic field more vigorously and tends to be more restless, marked by frequent eruptions and by large dark spots wandering across its face. A star that turns slowly is calmer, quieter, its surface more settled, its activity gentler. The spin is the engine beneath much of what a star does, and the pace of that spin sets the tone of the star's whole character. Now consider how a star loses its turning as it ages, for the mechanism is one we have already met in the story of the newborn sun. A star sheds a steady wind of particles into space, a soft and constant breeze streaming outward from its surface in every direction. The star's magnetic field reaches far out and guides that wind, holding onto it for a great distance before finally releasing it into space. And as each gust of wind is flung outward along those magnetic lines, it carries away with it a tiny share of the star's rotation. Gust by gust, age by age, this magnetized wind gently breaks the star, so that over billions of years it turns ever more slowly, slowed continuously by its own quiet breath. The effect in any single moment is imperceptible, far too slight to measure across a human span. But summed over the long reaches of a stellar lifetime, it is profound. A star that spun quickly in its youth becomes in its old age a slow and gentle turner, having handed much of its rotation, little by little, to the wind that streams away from it into the dark. Because this breaking is so steady and so reliable, the turning of a star can serve as a rough measure of its age. Young stars spin quickly and are magnetically restless, crowded with spots and frequent flares, their surfaces active and disturbed. Older stars, having given much of their spin away to the wind, turn slowly and grow calm, their activity fading toward quiet. So a fast-spinning star is, as a rule, a young one, and a slow-spinning star is, as a rule, an old one. The pace of the turning is a kind of clock, ticking down across the long life of the star, its slowing hands telling the star's age. there is a quiet symmetry here worth pausing on. At the very beginning of a star's life, we saw the young star had to give away most of its inherited spin in order to form at all, shedding rotation to its jets and its wind and its disk. And now, across the whole rest of its life, the star goes on giving its spin away, more slowly but by the same means, the magnetized wind carrying rotation outward, gust after gust. From birth to old age, a star is forever handing its turning back to the space around it, first in a rush and then in a long, gentle exhalation lasting billions of years. And in every case, the turning is not destroyed, only moved, carried off into the thin wind that fills the space between the stars. The rotation a star sheds does not vanish. It streams outward with the escaping gas, out into the same kind of medium from which the star was born, mingling back into the slow motions of the galaxy. The star slows, the wind carries its lost spin away, and the great accounting stays balanced, as it always does. The turning that a cloud once gave to a star, the star gives quietly back, across the long, patient span of its life. This slow breaking gives us a gentle way to sort the stars by age simply by watching how they turn. Gather together a great crowd of young stars, freshly formed from the same cloud, and you will find them spinning briskly, restless and active, their surfaces crowded with spots and frequent flares. Return to look at an aged population of stars, long settled into their lives, and you will find them turning slowly, calm and quiet, their activity faded to a whisper. The turning sorts them out. Fast and lively marks the young. Slow and gentle marks the old. The spin becomes a kind of quiet register of how long each star has been shining. There is a lovely closing of the circle in this. A star begins its life having just shed most of its turning in the rush of its birth, handing rotation to its jets and its disk and its planets in order to form at all. And then it spends the whole rest of its long life continuing to hand its turning away, only far more slowly now, gust by gust into its wind. The giving away never really stops. It only changes pace, from the swift shedding of youth to the long, patient exhalation of age. From first to last, a star is a thing that turns and slowly gives its turning back to the space around it. So the stars, like the worlds, are forever handing their turning around, giving it away and passing it on, never truly losing it. But there is one moment in the life of a star when this gentle exchange is interrupted by something sudden and extreme, when the slow giving away is overtaken by a violent gathering in. It is the moment of collapse at the end of a massive star's life, and it produces the fastest turning objects in all of nature. It is to those extreme spinners and to the furthest reach of the scatter effect that we turn next. Part 12. The extreme spinners. The same gentle scatter effect that gives a star its spin has a far more dramatic expression at the very end of some stellar lives. All through this story we have followed a single rule, that gathering a turning thing inward makes it spin faster, and that the deeper the collapse, the more extreme the speeding up. Now we come to the place where that rule is carried to its furthest limit, where collapse goes as far as nature allows, and the turning that results is faster than anything else the universe contains. When a truly massive star exhausts the fuel at its core, that core can no longer hold itself up, and it collapses catastrophically. In a matter of moments, a core roughly the size of a star falls inward upon itself, shrinking down to a sphere only a few miles across, a ball so dense that the matter within it is packed beyond anything we can easily imagine. This is one of the most extreme collapses that ever happens, a whole stellar core gathered from a great width down to the size of a small city, almost in an instant. And the turning obeys the rule as faithfully as ever. Remember what collapse does to rotation. Gather a spinning thing inward, and it must spin faster to keep the motion it already had. Here the gathering is enormous, from the width of a star down to the width of a city, and so the speeding up is enormous to match. A stellar core that once turned slowly, perhaps once in many days, is wound up by its collapse into something that turns many times every second. The gentle rotation of an ordinary star becomes, in the space of that fall, a blistering spin faster than the eye could ever follow, faster than almost anything in nature. These collapsed cores become spinning beacons. Many of them sweep beams of radiation around as they turn, streaming out along particular directions, so that as the object rotates, the beam swings around like the light of a lighthouse. From far away, we catch that beam each time it sweeps past us, arriving as a steady, astonishingly regular pulse, one flash for each turn of the object. The pulses are so precise, so metronomic, that they can rival the steadiest clocks, each tick marking one rotation of a city-sized ball, turning many times a second out in the dark. The very fastest of these objects turn hundreds of times every second, their surfaces racing around at a sizable fraction of the speed of light. It is difficult to hold such a thing in the mind, a solid body more massive than the sun, packed into a few miles, whirling around hundreds of times in the span of a single heartbeat. Some are spun up to these tremendous rates by drawing in material from a companion star, the infalling matter delivering yet more turning and winding them faster still, until they are among the most rapidly rotating objects that exist anywhere. And here is the point that ties it all back to the beginning of our story. This blistering rotation was not created in the collapse. It was inherited, exactly as the sun's gentle turning was inherited, and the planet's turning, and the turning of everything else we have followed tonight. It began as the ordinary, unremarkable spin of a normal star, itself inherited from a cloud. The collapse did not invent the motion. It only concentrated it, wound it to an extreme, took the same ancient turning and packed it into so small a space that it became ferocious. The fastest spin in the universe is an old, slow rotation, gathered as far inward as nature can gather it. Even these extreme spinners do not turn forever at their peak. They slow again, very gradually, as they radiate their energy away into space, their rotation winding down over long ages, just as everything else's does. The turning that was concentrated so violently in the collapse is bled away again, slowly, gust by gust and pulse by pulse, so that even the fastest spinners in the cosmos are, across the great reach of time, quietly winding down. The rule holds at every scale and in every direction, in the winding up of collapse and in the slow unwinding that follows. Collapse can go further still, past even this, to the point where the gathering is so complete that not even light can escape from what remains. And even there, at the very edge of what can exist, rotation endures. A collapsed object of this kind is famously simple, describable by only a very few properties, almost nothing about it left to distinguish one from another. And yet its turning is one of the precious few things it keeps. Where nearly every other feature is erased, the spin survives, one of the last inheritances such an object carries with it beyond the edge of sight. Most of these darkest objects were born turning and stayed that way. They formed from collapsing, rotating cores, wound up by the same effect as everything else, and many were fed afterward by disks of material spiraling inward, each stream of infalling matter adding a little more turning as it arrived. So they rotate, some of them nearly as fast as the laws of nature will permit. And a turning object of this kind does something stranger than any world or star. It drags the very fabric of space around with it as it spins, so that nothing close by can remain truly still, everything nearby swept gently along by the turning of the dark. That dragging of space, harnessing the object's rotation, is thought to power some of the brightest and longest streams of energy seen anywhere in the universe, great beams flung outward across enormous distances, driven in part by the spin of something from which light itself cannot escape. It is a fitting place for the extreme end of our story to arrive. The faint stir of a cold cloud, wound tighter and tighter through collapse after collapse, ends its journey here, in the blistering turn of a collapsed star and the space-dragging spin of the darkest objects there are. From the gentlest beginning to the most extreme end, it is one long, unbroken turning, the same motion carried all the way down. It is worth pausing on just how precise these spinning beacons can be, because their regularity is one of the quiet marvels of the sky. Each pulse of light marks one full turn of the object, and because the turning is so steady, the pulses arrive with extraordinary reliability, one after another, spaced as evenly as the ticking of a fine clock. Some of these objects keep time so faithfully that their steady beat rivals the most careful clocks ever built on Earth. A city-sized ball, more massive than the sun, whirling many times a second far out in the dark, nonetheless keeps a rhythm we can count on, its turning translated into a pulse of astonishing constancy. The spin becomes a heartbeat, and the heartbeat almost never falters. And yet even these most faithful of timekeepers slowly change. As the object radiates its energy away, its turning gradually eases, and the pulses arrive just a little more slowly with the passing of long ages, the beat stretching out by the tiniest degree. It is the same story once more, the same rule we have followed the whole way through. Nothing keeps its turning forever unchanged. Even the swiftest spinner in all the universe is, across the great reach of time, quietly winding down, handing its rotation back to the space around it. The fiercest turning and the gentlest obey the same patient law, and both, in the end, slowly relent. We have followed the turning from the faintest cloud to the fiercest spinner, across the whole range of what a single object can be. But the story does not end at the scale of stars and their remnants. It scales upward once more, past the individual worlds and suns, to the great wheels of the galaxies, and then to a final and surprising stillness, waiting at the very largest scale of all. It is to those largest turnings, and to the quiet that lies beyond them, that we now turn. Part 13. The Largest Turnings. The same story of turning scales upward past single stars and their remnants, all the way to the great wheels of the galaxies, and then, at the very top, to a final quiet that is one of the most surprising facts in all of this. We have followed the spin from the smallest tumbling fragment to the fiercest collapsed star. Now we lift our gaze to the largest turning things there are, and then beyond even them, to ask whether the whole of everything turns as its parts do. Galaxies turn, immense and unhurried, on scales that dwarf everything we have spoken of so far. Our own galaxy is a great flattened disk of hundreds of billions of stars, slowly wheeling around its distant center. The Sun, carrying the Earth and all its sibling worlds, sweeps around that center in a single enormous circle, and one full journey takes hundreds of millions of years to complete. We are riding upon a turning far grander than the turning of any planet, a slow, stately rotation so large and so gradual that a single loop of it outlasts whole chapters in the history of life on Earth. And notice the shape of the galaxy, for it should look familiar by now. A spiral galaxy is a flattened disk, broad across its face and thin from top to bottom, with its stars gliding around a common center in a shared direction. It is the same shape we met at the scale of a newborn solar system, the same flattening that turning always produces, now written across a span of light so great the mind can barely reach it. A spinning collection of matter, whether a cloud around a young star or a galaxy of 100 billion suns, settles into a disk. The principle does not change with size. Only the scale does. Where did the turning of the galaxies come from? The answer echoes the beginning of our whole story, only carried to the largest scale. In the earliest times, when the great structures of the universe were first drawing themselves together, neighboring clumps of forming matter tugged upon one another with their gravity. As they pulled and passed and gathered, these neighbors gently talked each other, each one's uneven pull setting the other slowly turning. A galaxy's spin, in this picture, is a gift from its neighbors, an inheritance from the gravitational tugging of everything that formed alongside it in the young universe. So even at the scale of galaxies, the turning was not created from nothing. It was passed along, handed from the gravitational pulls of the early universe into the slow rotation of the great wheels of stars. The same theme runs through every scale we have visited tonight. A cloud inherits its turning from the galaxy and from its own turbulence. A star inherits its turning from the cloud. A planet inherits its turning from the disk. And a galaxy inherits its turning from the tugging of its neighbors in the young cosmos. At every level, the spin comes from something that came before, never made, only received and reshaped. There is one more question waiting above even the galaxies, the largest question of all. If everything within the universe turns, from moons to planets to stars to galaxies, then does the universe itself turn? Does the whole of everything, taken together, wheel around some grand axis, the way each of its parts does? It is a natural thing to wonder, having watched turning appear at every scale we have climbed. Surely, we might think, the pattern continues all the way to the top, and the cosmos as a whole must spin as its pieces do. But as far as anyone has been able to measure, it does not. The universe as a whole appears to have no overall turning at all, no axis it wheels around, no grand rotation summing up the countless smaller ones within it. Every turning thing we know sits inside a hole that seems, itself, to be perfectly still. The moons turn, the planets turn, the stars and galaxies turn, and yet the great containing whole that holds them all shows no sign of turning in the slightest. The pattern that filled every scale beneath it simply, quietly, stops. There is something strange and beautiful in this, worth resting with as we near the end. All that turning, at every level, and above it a stillness. The universe is filled to its brim with rotation, and yet, in its totality, it does not rotate. Why the turning should fill everything within, and then vanish at the scale of everything together, is one of the quiet, open questions of the largest cosmology, a puzzle without a settled answer. It is a subject this channel has drifted toward on an earlier night, and it is enough here simply to notice the strangeness of it once more, and to let it be. Perhaps there is a gentle sense to it after all. For every turning we have followed came from something that came before, one body's spin handed on from another's, a cloud from a galaxy, a star from a cloud, a galaxy from its neighbors. But there is nothing before the universe, and nothing beside it, no neighbor to tug it, no larger thing to hand it a turning. And so, alone and entire, with nothing outside to set it spinning, the whole of everything rests still, cradling within it all the turning there is. The parts inherit their motion from each other. The whole, having no other, simply holds them all. The turning of a galaxy holds one more quiet puzzle worth touching on gently. When we watch how the stars in a galaxy move, we find that the outer ones circle the center far faster than the visible matter alone would seem to allow. By all the ordinary reckoning, the distant stars ought to lag behind, turning slowly at the thinly populated edges. Instead, they keep pace, sweeping around more quickly than expected, as though held and guided by far more matter than we can see. This is one of the threads that led to the idea that galaxies are embedded in great unseen halos of material, an invisible presence felt only through its pull, shaping the rotation of the visible stars. So even the turning of the galaxies carries a hint of something hidden, a reminder that the visible wheel of stars may be only the part we can see of a much larger turning whole. It is a thread this channel has followed on other nights, and we need only touch it lightly here. What matters for our story is that the galaxies turn, grandly and slowly, their rotation inherited from the young universe and shaped by more than meets the eye, and that this turning is the largest ordered motion we can point to before the pattern, at last, gives way to stillness. And that stillness at the top casts the turning below it in a softer light. Every spin we have followed tonight, the Earth's day, the sun's slow month, the fierce whirl of the collapsed stars, the grand wheeling of the galaxies, all of it turns within a great calm that does not turn at all. The motion is real, and it is everywhere, and it is old beyond reckoning. But it is held, all of it, inside a stillness larger than any of it. There is something restful in that thought, a universe full of turning, carried gently within a quiet that never moves. Part 14. Why the turning never stops. Having climbed all the way from the faintest stir of a cloud to the stillness above the galaxies, we can return at last to the question we have carried the whole way, and to a final gentle reassurance hidden inside it. It is natural, having seen how turning slows, to wonder what would happen if it all simply stopped. What if the planets stood still, the stars ceased their rotation, the great wheels of the galaxies froze in place? The answer reaches back to the single rule that has governed this entire story, and it is a quiet comfort rather than a loss. Turning cannot simply be destroyed. It can only be moved. This has been true at every scale we have visited tonight, and it is the reason the turning of the universe does not, and cannot, simply wind down to nothing. A planet may be slowed by the tides, but its lost rotation is not erased. It is passed to the orbit of its moon, handed outward, conserved in a new form. A star may be braked by its wind, but the spin it loses is carried off into space by the escaping gas, never gone, only relocated. Wherever turning seems to disappear, it has in truth only moved along. To stop everything at once, the universe would need somewhere to put all that turning, some great still place ready to absorb it, some great motionless reservoir into which all the spin of all the worlds and stars could drain away and vanish. But there is no such place. The turning has nowhere to go except from one body into another, from a spin into an orbit, from a star into its wind, from a world into its moon. And so it continues, patient and undiminished in its total, forever handed along, but never truly lost. The day lengthens, the moon drifts outward, the star quiets, the collapsed remnant slowly unwinds. And in every single case, the motion has only moved. It has never gone. This is the gentlest possible note on which to let the whole story rest. The turning of the ground beneath you, the turning of the sun that warms your days, the turning of the whole slow galaxy you ride within, none of it was made in the moment these things formed, and none of it will ever fully cease. Each of these motions was inherited, drawn down from something older, wound tighter by the patient fall of gravity, passed along from cloud to disk to world. And each will go on being passed quietly along, in one form or another, for as long as there is anything left to turn. Think back over the long trail we have followed. It began with a faint stir in a cold and enormous cloud, a rotation so slow it could never have been felt. Gravity tipped that cloud into collapse, and the fall wound the turning tighter, concentrating it inward. The spinning gas flattened into a disk, and from that disk a star was born at the center, and worlds were gathered in the surrounding sheet, each inheriting the disk's single direction of turning. The star gave most of its spin away to its wind and its jets and its planets, and the planets carried that turning off into their orbits and their days. And from there the turning spread into everything. It settled into the steady rhythm of the Earth's rotation, the day and the night we live by. It was slowed and shaped by the tides, until moons locked to their worlds and kept one face forever turned inward. It wound down across the long lives of the stars, carried off gust by gust into the wind. It was gathered to a ferocious extreme in the collapse of dying stars, and it endured even in the space-dragging spin of the darkest objects there are. It wheeled slowly through the galaxies, inherited from the tugging of neighbors in the young universe. Everywhere, at every scale, the same ancient motion, handed on and reshaped, never made and never lost. So the next time you watch the sun settle toward the horizon, you might remember what you are truly seeing. It is not the sun going down. It is the ground beneath you turning, carrying your part of the world gently away from the light, exactly as it has done every evening of your life and every evening long before there was anyone to watch. And that turning of the earth is not the earth's invention. It is the turning of an ancient cloud, wound down through the disk and settled into the rhythm of your days, a motion older by far than the world that carries it. There is a deep restfulness in knowing that this turning asks nothing of you. It does not need you to notice it, or to understand it, or to keep it going. It turned for billions of years before you were here, and it will turn for billions more after this night has been forgotten. The earth will carry you through its days whether you watch or sleep. The sun will turn in its slow month. The galaxy will wheel through its unhurried circle, hundreds of millions of years to a single loop, carrying you along inside it without the smallest effort on your part. You are being turned, right now, as you rest. The floor beneath you is turning. The sky above you is turning. The whole great wheel of the galaxy is turning, and you are riding along within it, carried without sound and without sensation through the quiet dark. There is nothing you need to hold on to, and nothing you need to keep spinning. The turning was here long before you, and it will carry on long after, patient and gentle and utterly at ease. So the question we carried in from the very beginning has quietly answered itself, and the answer turns out to be gentle. Where do the planets and the stars get their spin from? Not from any push, not from any hand that set them going, but from an inheritance, drawn down out of the faint turning of an ancient cloud and wound tighter by the patient fall of gravity. The turning was never made. It was only received and passed along and reshaped, from the cloud to the disk to the world, from the star to its wind, from the collapsing core to the fierce spin of what it leaves behind. It is all one motion, very old, handed quietly down the long chain of things. And that is a restful thought to carry into sleep. The turning beneath you asks nothing, and it will not stop. It was here before you, gathered out of the dark long ago, and it will go on turning long after this night has faded from memory, passed gently onward as it always has been. And so we leave the planets and the stars where we found them, turning slowly in the dark as they have since, long before there was anyone to notice, each one carrying, without effort, a motion older than itself. There is nothing you need to hold on to now, and nothing you need to keep spinning. Let your thoughts slow. Let the turning of the world carry you the rest of the way. Sleep well, and good night.